Decided to demonstrate Kafka support, as Kafka is very powerful and widely used technologies. And with the new Spice data connector, we can now enable very interesting new scenarios I'm going to demonstrate next. In my local setup, I have Kafka running locally. And I have a single topic that simulates real-time orders. Imagine there is a warehouse where we have orders information populated in real time. And here's example Kafka message representing this information. With Spice 1.6 release, I can now connect to any arbitrary Kafka topic using the following configuration. In my demo Spice pod, I need to point to target Kafka topic. In my case, it's orders events. Provide main configuration parameters, how find Kafka brokers and how to authenticate. In my case, it's just plain identification, localhost, and specify local materialization so we can aggregate information from the Kafka topic. And that's it. So this is the only configuration required. I'll do Spice run. Spice has started, and we can see that we started populating new information from Kafka. So it's now available in Spice, and we can query this information. Okay. I'll start Spice REPL. Okay, let's check if table is available. Yes, table is available, and just let's check the schema. And we can see that we have a schema automatically inferred by Spice. In real time, when we receive messages from Kafka, we can automatically detect the target schema and all fields and the types. So this is how it works. You don't need to specify any information, just need to point to target Kafka topic. And now we can do some demo queries. I'll start from query representing real-time KPI. For example, I would like to calculate some statistic based on last hour information. So in my case, I can use the query where I filter all information to take only last hour and do aggregation. Let's give it a try. Yep, we just run the query and it worked, and it uses the real-time Kafka stream. So if I rerun the query, I should see different information. Right. So we have more customers, distinct suppliers, and we have an increased number of orders. So basically, this is the first step how you can use Kafka to connect to Kafka topic and start querying your messages. But we can do a few other things. For example, we can, let's say we would like to enrich this information with other data sets. For example, let's say we have lookup tables stored on S3 Parquet files. We can enable those data sets as simple just as adding configuration for them to SpicePod. In my case, I will add customer, nation, and supplier dataset, and they will be accelerated locally in Spice. I hit save, and you can see that those datasets automatically loaded. We detected changes in SpicePod configuration, and we loaded those datasets. So if now I can do show tables, we can see new dataset added, and those data sets from S3 Parquet files. So what I'm going to do, I will join information from Kafka orders, with nation and supplier information, lookup tables, and run the query. And we can see that now with the single query, we got information from several different sources. We've got main information from Kafka and names, nation names from S3 using joins. But what else we can do? We can add our some model. Let's say I would like to work with those datasets using LLM. So what I will do, similar to Luke's demonstration, I just enable simple configuration in my SpicePod, telling, okay, I would like to use OpenAI GPT 4.1 model, and this is my identification key. So I hit save, and we can see that model was automatically loaded and ready for usage. So I'll open another terminal. Run Spice Chat. Spice Chat is our simple version of tool that you can use to invoke the models. And I can say, for example, what data sets are available. And the model confirmed that it has access to all data set. We can ask, for example, how many queries in our Kafka topic, how many orders do we have? And the model was able to detect basically created query to the right data set and show information. It's pretty fast. It's just in 3 seconds. But we can also do something more interesting. Like let's ask to create some chart, for example, for us. Show total spent by customer nation as ASCII chart. And let's see if model will be able to complete this query. Yeah, we can see that model was able to receive this information, and Brazil seems to be the customers from Brazil did the most, spend the most amount of money on the orders. And interesting, it will be interesting to double check the model calculation, how specifically it was able to get this information and display. For this, we will use observability tool similar to Luke's demonstration. I can go observability mentor, and I can find my chat request. This is our query show total spent by customer nation as ASCII chart. And this information and all logs are propagated from my local SpicePons instance through special configuration. It's called management. And this configuration, all logs and traces automatically become available in our cloud version. So in this specific request, what we see that model use tool to list all data sets. Then the model asks for a specific schema for each data set to understand what fields available, what they type. And the model come up with this SQL query based on this information, and we can double check if it's correct. And the calculation was sum like quantity multiplied on unit price, it's total spend, which is correct for me. And the model was able to join this information based or this key with lookup tables to provide user-friendly names like Brazil for us. And another thing that we can do is because ASCII chart probably not the best way to represent BI and visual information. We support Power BI as a tool, and we can connect through Power BI to the SpySpot that I'm running locally. I have a Power BI desktop running on a virtual machine, and let's see if I can connect it to my Spice instance. Data. For this, we support special Spice Power BI connector. I have it already installed. I need to specify my hostname. G and port. And yeah, we see our Spice runtime and schema, and we see our orders table. We can now connect it to Power BI and create first simple chart. For example, I would like to get number of orders in real time. So it's connection created. It's loading. Okay. It will be our chart, and we will aggregate information by order count. And the last thing I need to do is to enable refresh. For example, we will be refreshing every second. Okay, hit save. And we can see live data through Power BI from real-time Kafka stream. Just to recap what we was able to achieve so far in just a few minutes. We was able to connect through Kafka using this simple configuration. We added few other data sets from different source, from S3 Parquet files, and we were able to complete federated queries by joining data from different data sets, tables and data sources. We used model asking to get some information and insights from Kafka using LLM and using this 5 lines of code. And we also connected Power BI to real-time Kafka stream.